Welcome back to Applied Algebra and Trigonometry. We're going to continue talking about solving equations. I'm going to save the application problem that I promised you until video C. I want to talk about two other types of equations that you can solve. You may need to solve a proportion. Well, what is a proportion? It is an equation that sets a fraction equal to a fraction. There's a very simple one. 3/6 equals 1/2. They are equivalent measures, equivalent fractions. Set them on either side of an equal sign and you have a proportion. And if we had, instead of that 3 an x, we would have a proportion that we could solve. And we could figure out what x should be. And most of you are probably looking at that and saying, yeah, I'll cross multiply. Okay, that will work. But wait a minute, hang on just a minute. This is something that people often struggle with. Let's take a look at some situations where if you don't take a second look, you may think you can cross multiply. So I'm going to ask you, and I'm going to pause after each one to give you a moment to think, whether a given expression could be simplified or solved by using cross multiplication. Can you cross multiply? Have an answer? The answer is no, you should not cross multiply here. You should find the LCD, or the least common denominator, and add. Would you cross multiply to evaluate x over 3 times 4 over 6? No. You would multiply straight across. No LCD needed. Multiply straight across. Okay, let's see. Another example. Would you cross multiply here? No, you would not. You would multiply by the reciprocal. By the reciprocal. What about this equation? Notice that I said equation. None of the other expressions above it have an equal sign. This is the only one that has an equal sign, and this is the only one to which you can apply cross multiplication. So, yes. Thus, you should never try to cross multiply unless there is an equal sign between those ratios, or between those fractions. Okay, let's take a little closer look at this one. All right, let's actually do this one by cross multiplication and see what happens. By the way, cross multiplication actually isn't the best way to do this one. I'll redo this one at the very end for those of you who want to see it. Okay, so if we cross multiply, we get 5 times L equals 8 times 4.20, which is 5L equals what? 1633.60? Yes, and if we divide both sides by 5, what will we get? Okay, on the left those will cancel, giving us L equals 6.72. All right, and I just did a quick check on my calculator, putting in 6.72 for L in my original equation, and discovered that yes, on both sides I get a decimal of 1.6. It is equal. This is correct. And we will move on to another example for which we can solve using cross multiplication. Now this problem is a much better use of cross multiplication because I have an x here and an x here. So I'm going to multiply those. That's going to give me x plus 1 times x plus 2. Those are binomials, each of them, binomial times a binomial, and on the other side of the equal sign, I will have 20. Now, to multiply these, I'm going to have to distribute everything in the first binomial to everything in the second binomial. Some of you may have memorized FOIL, first, outer, inner, last. But let's see, x squared plus 2x plus 1x plus 2 equals 20. Combining like terms equals 20. 20. Now, I can factor? No, I can't. If I factor, I'll be right back where I started. You see, I don't have a 0 here. We want 0 on that side before we factor and move towards solution. So let's get rid of that 20 over there. Let's make it 0 on that side. But I have to do unto one side as I do unto the other. I'm going to subtract 20 from both sides, giving me a negative 18 over here and a 0 on the right. Now, if I can just factor what's on the left here, we'll be doing well. All right, x times x will give us x squared. And the factors of negative 18 that add to be a positive 3 are 6 and negative 3. So quick check, yes. Multiplying those two binomials will give us the trinomial we started with. Now, take a look at this. If the first factor is equal to 0, you multiply it by the second factor to get 0. If the second factor is 0, then when you multiply that by the first factor, you will still get 0. That is why we now take those two factors and set them each equal to 0 separately. X plus 6. If this is equal to 0, that entire expression is equal to 0. If x minus 3 is equal to 0, the entire expression is equal to 0. So let's solve each of these separately, subtracting 6 from both sides here, and adding 3 to both sides here. So if x equals 3 or if x equals negative 6, our original equation is true. But let's check it, make sure we haven't made a mistake. All right, so let's put in negative 6 first. All right, for every x, I'm going to put in one of my answers, the same answer each time, checking each one separately. Okay, so negative 6 plus 1 is negative 5 divided by 2 equals 10 over negative 6 plus 2 is a negative 4. So negative 5 halves equals negative 10 fourths, maybe. Okay, negative 5 halves. Let's see if I simplify this, dividing this by 2, dividing this by 2, I get negative 5 halves. Okay, here is something to remember. Negative 5 halves equals negative 5 over 2, and it's also equal to 5 over negative 2. The negative in either the numerator, the denominator, or out in front is equivalent. Each one of those expressions of the fraction is equal. Now let's check the positive 3. We have an x plus 1 over 2 equals 10 over x plus 2. So if we put 3 in for x, in each case we get 4 over 2 equals 10 over 5. Let's see, 4 divided by 2 is 2, and 10 divided by 5 is 2. In both cases, they check. This one was correct by this check, and this one was correct with the last check that we did. There are our two answers. We have solved this original equation by cross multiplication. But this is an applied class. There are some times when you can do something mathematically, but with the application you are doing, a negative may not make sense. An irrational number, less likely, but might not make sense. You have to apply it to your situation. For instance, if I ask you to find a length using this equation, we would have to exclude any negative numbers because length is positive. If you were doing a business application, okay, and you wanted to know some number that would help you make a profit, you do not want a negative profit. So you would exclude any negative solutions. Okay, very quickly, let me make note of one other type of equation you may be asked to consider. What if you have something like this? We'll call this example 3. The absolute value of x equals 9. Remember, an absolute value means the distance of this number from 0, okay? Practically, what it means is whatever's inside that absolute value sign, make it positive. If it's already positive, don't worry about it, okay? So whatever's inside there is either going to be negative or positive. And in fact, whatever's inside there is either going to equal positive 9, obviously the absolute value of 9 is 9, or whatever's inside of there is going to equal negative 9 because the absolute value of negative 9 is 9. So just like we did before, we can check this. The absolute value of x equals 9. My first x that I'm checking is this 9. Absolute value of 9 equals 9. Once again, I'm going to put in some value for x and prove that it equals 9, hopefully. Yes, let's see. I'm going to put this negative 9 in for x. Is the absolute value of negative 9 equal to 9? Yes, it is. This checks. This checks. Yes. So these truly are the answers. Let's do another example. Okay, we'll do another absolute value example. Here's example 4. Okay, the absolute value of x minus 2 equals 5. We are still solving for x. The way we are going to do this is we're going to take whatever is inside that absolute value sign, and we're going to set it equal to the positive 5 that we see there. But also, if that entire expression equaled negative 5, and then we took the absolute value of it, we would get positive 5. So if those two things, if either of those would solve that equation, what is the x? Now we just have to solve for that. So adding 2 here and adding 2 here, I'm going to get x equals 7. For the other answer, if I add 2 here and add 2 here, I'm going to get x equals negative 3. Two answers. Putting in a 7 for that x. Okay, and what is that supposed to equal there? It's supposed to equal to 5. Okay, 7 minus 2 is 5. Absolute value of 5 is 5. That checks. All right, now I'm going to put in a negative 3 for my x. Once again, I'm using the parentheses here to make sure that I get my negative inside the parentheses. All right, and that gives me a negative 5 inside the absolute values symbols, and 5 equals 5. There we go. There's an answer, and there's the other answer. Those of you who are not curious about another way to do example 1 may move on to the third video in this series, letter C. It includes an application problem, and it talks about how to use your handy-dandy TI-89 calculator to good advantage. Okay, see you in video C, and everybody who's curious, stick around. Okay, you have a calculator in your hands, I hope, as you're watching this. Notice L is our variable. It is almost isolated on the left-hand side, and when we're solving equations, we are trying to isolate the variable. It's divided by 4.20, so let's just multiply both sides by 4.20. And those are fractions, so let's put it over 1. On this left-hand side, those will cancel. So we will have just an L equals 8 times 4.20 divided by 5, which is equal to 6.72, which we already checked. You wind up doing the same thing in the end, right? 8 times 4.20 divided by 5. That's why cross multiplication works. Now check out video C.